Let's analyze the case of a majority classifier ensemble a little bit more formally. If we have three classifiers, M1, M2, M3, which each have a probability P of making a mistake on a particular example, and these probabilities are independent of each other, what is the probability P majority that the majority ensemble also makes a mistake? And so when does it make a mistake? Well, only in the case where either two or three of the classifiers make a mistake simultaneously. So we simply have to sum together the binomial function for these two cases. And the binomial function is the standard formula from probability, which tells us if we flip a coin 3 times and the probability of heads is P, then what is the probability that we get 2 heads or 3 heads, and so on. So we can just use this formula. We can sum it for the case of K, so the number of models that are making a mistake either being 2 or 3. And then we will see that if P is something like 10%, then P maj is something like, P majority is something like 0.028, so less than 3%. So we can see formally why this works, why the majority classification here gives a error rate which is smaller than each of the individual classifiers, which is going into this majority ensemble. I already gave you one caveat, which is that the errors have to be independent. And there is another caveat, and think about what happens if P, the probability that each of these models has of making a mistake, is larger than 50%. Does this still hold?